So being able to crunch numbers is one thing, but more important is being able to understand what equilibrium is and what those values actually tell us. So it's not just about calculating a number, but what does that number actually mean? So if we look at this particular situation right there, where we have a K value of 0.0814. Now let's think about this in terms of math. So if we have a number like this, that number is less than 1. What does that tell us about the respective values of the products and the reactants? Well, if we've got a number that's less than 1, it means the number of our reactants is going to be higher. So the number on the bottom is larger, which means that the pressure of HI squared is going to be greater than the pressure of H2 times the pressure of I2. So since the K value is less than 1, we know that the pressure of our reactants is going to be greater than the pressure of our products multiplied by each other. So that means in this particular reaction, it is mostly going to be reactants. Another way we would say this is this reaction favors reactants. So once this system has reached equilibrium, we are going to have more HI than we do H2 and I2. We can tell that just by looking at this number right there. So knowing that value, looking at this reaction, will tell you then, hey, we're not going to produce a lot of H2 and I2. So think of this in like a laboratory. So if you get a really low percent yield of H2 or I2, well, it would make sense because not all of it's going to react. So that's why it's important to be able to read these numbers. So here's another one, and in this case this is a very large number. It's 2400, 2.4 times 10 to the third, which means that our top number in this case is going to be larger because we've got a larger number on top, so we have a value greater than 1. And so that means the concentration of N2, it's an N, sorry folks, times the concentration of O2 is going to be greater than, and in fact much greater than, the concentration of NO squared. So in this case, we're going to have mostly products. So this reaction does go pretty close to completion, or very, very far away, or mostly it's going to be product favored. This is what you need to know, and don't just memorize this. Really try and understand what it is I'm talking about here, why it is that if KEQ is greater than 10, we say that's mostly products, so equilibrium lies far to the right. It's going to go towards the products. But if equilibrium is less than 0.1, we say, hey, it's mostly reactants. Doesn't really go that far towards products. And if KEQ is 1 or pretty close to 1, we're going to have relatively equal amounts on both sides. This one is going to be the most rare. So if we look at this particulate representation, which just shows AB turning into A and B, and so AB obviously is going to be the two that are joined together, and A and B we could say that A is blue and B is green. So if we do a real quick count here, we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, or somewhere around there. I might have skipped 1 or 2. And then if we look at the A's, A is blue, we said 1, 2 of them. And so, hey, we can just do that little count right there, and we can see that the concentration of AB is going to be significantly greater than the concentration of A, even the concentration of A times B. And so, in this case, that means the value of our equilibrium constant for this particular reaction is going to be less than 1. Now, we don't know what the exact value is. We can't really calculate the exact value from this picture. We just know that whatever it is should be less than 1 because, in this particular case, the reactants are favored over the products.